So today's topic, we will discuss about the differentiation rules. So as a review, napag-aralan natin that there are six basic differentiation rules. We have the constant rule, na kung saan yung derivative of every constant is zero. The power rule, that is given by n x raised to n minus 1. So the rule here is drop the exponent, copy the exponential form, then subtract the exponent. We have also your constant multiple rules, the sum and difference rules, the product rule, and the quotient rule. So again, these are basic differentiation rules natin. Let's proceed to the other rules and advanced differentiation rules na kung saan hindi kayang isolve ng mga basic differentiation rules. So gagamit tayo ng mga advanced differentiation rules. So the objectives of this lesson is that you will be able to illustrate the chain rule of differentiation, solve problems using the chain rule, compute higher order derivatives of functions, and illustrate the implicit differentiations. So pag-aaralan natin in this PowerPoint the chain rule of differentiation, how to solve for the derivative of a certain function using chain rule, and also the higher derivative of functions. Hindi lang first, meron tayong second, third, fourth, fifth derivative until to the nth derivatives. And also the implicit differentiations na hindi kayang isolve ni basic, and also the chain rule, as well as the higher ordered derivatives of functions. So dako tayo sa pinaka-advanced, we have the chain rule, and ito yung formula niya. So the derivative of your function is equal to the f prime of g of x times the g prime of your x. So ano yung sinasabi sa chain rule? If y is a differentiable function of u and u is a differentiable function of x, then y can be regarded as a function of x, and that is given by this formula. So ito yung formula ng ating chain rule na dapat nating i-memorize. That is dy over dx is equal to dy over du multiplied by du times dx. That is, the derivative of y with respect to x is the derivative of y with respect to u multiplied by the derivative of u with respect to x. That is your chain rule. So we have here table, examples of non-differentiable and differentiable functions when used with the chain rule. So yung nasa left part ng ating table, ito yung mga functions na hindi kayang i-differentiate gamit yung chain rule. Okay? Pero kayang i-solve ng ating basic differentiation rule. We have, for example, yung first function, which is y is equal to x squared minus 3, kayang i-solve ni basic differentiation. Gamit na tayo ng power rule and also your constant rule. Ganun din yung case ng second function, that is 2x plus 4, as well as the third function, 7x plus 8. Yung fourth function naman natin, pwede siyang gamitan ng product rule, and the last function, the quotient rule. On the right part naman, ito naman yung functions that is differentiable with the chain rule. Hindi kayang isolve naman ng basic differentiation rule natin. Example, the y is equal to the quantity of x squared minus 3 raised to 1/3. So hindi siya kayang isolve ni power rule. Okay? Kasi binubuo siya ng smaller function, which is the inner function, the x squared minus 3, and the bigger function, which is your degree, 1/3. Ganun din yung case ni y is equal to square root of 2x plus 4 until sa pinaka-baba. Okay? Yung pinakaibalan dito is that meron tayong inner function na naka-enclose sa parentheses with a certain degree. So again, gagamitan natin ng chain rule dun. Okay? For example, so find the derivative of g of x is equal to quantity of 4x plus 1 raised to 6. So fundamentally, yung chain rule gagana lamang by taking the derivative of the first function at x. Then i-multiply natin sa derivative by the derivative of your inner function. Thus, in the chain rule, the differentiation process involves decomposing the function So paano nga ba tayo mag-decompose ng function dito? So let's take again the example. G of x is equal to the quantity of 4x plus 1 raised to 6. So decomposing the function, ililet natin yung g of x natin to y. So ibig sabihin, your g of x is equal to 4x plus 1 raised to 6 can be rewritten by decomposition as y is equal to u raised to 6. So maglilet tayo ng y dito. Okay? Ng u rather. So lahat ng nasa loob ng parentheses, ililet natin as u. That is, your u is equal to 4x plus 1. Ibig sabihin yung y is equal to u raised to 6. So, medyo madali na siyang i-differentiate gamit yung power rule and other basic differentiation rule. Okay? So, kung meron tayong y is equal to u raised to 6, malalaman natin yung differentiation nito. That is, dy over du, that is the derivative of y, is equal to, so ano yung derivative ng u raised to 6? Applying the power rule, that is drop the 6, copy your exponential function, and then subtract your function, your exponent by 1. That is 6u raised to 5. Kaya yung dy over du po natin dyan is equal to 6u raised to 5. That is the derivative of your y, which in this case, y is equal to u raised to 6. So, ganun din yung case ni u, which is equal to 4x plus 1. Kukunin natin yung derivative niya. That is, du over dx, or derivative of u with respect to x, is equal to 4. Bakit naging 4? Kasi, by identity rule, yung x natin, derivative is 1 multiplied by 4, that is 4. Then the derivative of 1 is 0 kasi constant siya. So may iwan na lang si 4. That is the derivative of your u. Then alam natin na yung equation ng chain rule is dy over dx is equal to dy over du times du over dx. So substitution na tayo. Nakuha na natin yung dy over du, then nakuha na rin natin yung du over dx. So substitution tayo. Okay? So what is your dy over du? That is 6u raised to 5. And your du over dx is 4. Kaya naging 6u raised to 5 times 4 tayo. Then simplify po natin 6 times 4. That is 24. Copy yung u raised to 5. Is this the final answer? No. So kailangan nating ibalik yung u natin kasi naglat tayo ng u, right? So substituting back the value of u in terms of x naman. So, kanina yung u natin is 4x plus 1, ibabalik lang natin. So, yung 24u raised to 5 becomes 24 times the quantity of 4x plus 1 raised to 5, and that is the derivative of your function gamit yung chain rule. Another example. So, let's say for example, we will find the derivative of your f of x is equal to square root of 3x minus 4. So, paano natin kukunin yung derivative nito gamit yung chain rule? So, solution for this, we will decompose your function. Okay? So, yung f of x, ililet natin as y. So, ibig sabihin yung y natin is equal to square root of 3x minus 4. So, lahat ng inner function, ililet natin as u. So, what is our inner function here? 3x minus 4. Ito yung nasa loob. So, 3x minus 4, ililet natin as u. Thus, u is equal to square root of u, or that is u raised to 1/2. Okay? At yung u natin again is 3x minus 4. So, kukunin natin yung derivative ng y natin. That is dy over du. So, what is your derivative of y? So, ulitin lang natin, yung y natin is u raised to 1/2. So, applying the power rule, yung derivative ng y natin magiging ano? That is dropped the exponent, and then subtract the exponent by 1. So, therefore, derivative of y is 1/2 u raised to negative 1/2. So, dapat wala tayong negative exponent. So, simplify natin. The answer is 1/2 square root of u. Okay? Then, kukunin naman natin yung derivative ng u, or that is du over dx. So, 3x minus 4 yung u natin. Derivative ng 3x is 3. And derivative of negative 4 is 0. So, may iwan na lang si 3. That is, du over dx is equal to 3 na lang. And then, babalikan natin yung formula ng chain rule. That is dy over dx is equal to dy over du times du over dx. Nahanap na natin kanina yung dy over du, isa-substitute na lang natin dito. Nahanap na rin natin yung du over dx, isa-substitute na lang natin dito. So what is your dy over du? That is 1 half 1 over 2 square root of u. Then yung du over dx natin is 3. Right? Then simplify natin, multiply. That is 3 over 2 square root of u. And that is the final answer. Thus, that is not yet the final answer kasi kailangan nating balikan yung value ng u natin. So yung u natin kanina is 3x minus 4. Lahat ng u na nakuha natin magiging 3x minus 4 na. Thus, the derivative of your f of x is 3 over 2 square root of 3x minus 4. And this is the final answer. So, dako naman tayo sa general power rule. Katulad din siya ng chain rule. Okay? Katulad din ng concept ng chain rule, yung general power rule. So, if y is equal to u raised to n is a differentiable function of u, na kung saan yung u natin is a differentiable function of x, then for any real number n, d over dx times u raised to n is equal to n u raised to n minus 1 times u prime. So, parang chain rule din siya. Okay? So, we will apply the power rule here also. So, drop the exponent, then subtract by 1. But, yung pinagkaiba lang dito, we will multiply by the derivative of your function. So, yun yung pinagkaiba niya sa power rule. So, to identify the function u, note that it is usually the inside function in the given composite function. Kung yung function pa natin is a composite, kung ano ba po yung nakalagay sa loob ng parentheses or square root, that is your inner function or inside function, and that is your function u. Example. So, gamit tayo ng general power rule to find the derivative of the following functions. Letter A, f of x is equal to the quantity of 5x minus 2x cubed raised to 4. And then letter B natin is g of x is equal to cube root of quantity 2x cubed plus 3x squared. So, una natin kukunin yung letter A muna. So, our function is f of x. The inside function of letter A is what? Is 5x minus 2x cubed. So, ibig sabihin, we will let u, okay, maglilat tayo ng u, which is 5x minus 2x cubed kasi ito yung inside function natin. Then, kukunin natin yung derivative ng u, that is 5 for the derivative of 5x. So, yung derivative naman ng 2x cubed is 6x squared. Thus, your derivative of u is 5 minus 6x squared. And then you have, so ito na. So, yung function natin, or yung derivative ng function natin, letter A, is, so 4. So, drop natin yung exponent kanina sa letter A. Drop the exponent, which is 4. Copy the function, minus 1 yung exponent. So, naging 3 na lang siya. Okay? And then, multiplied by the derivative of u. That is 5 minus 6x squared. And simplify natin. Pagsamahin lang natin yung 4 at saka 5 minus 6x squared. That is 20 minus 24x squared. Multiplied by the quantity of 5x minus 2x cubed. And this is the final answer for letter A. Letter B. So g of x is equal to cube root of 2x cubed plus 3x squared. So ano yung inside function natin? Our inside function is 2x cubed plus 3x. By the way, yung cube root of 2x cubed plus 3x squared can be rewritten as the quantity of 2x cubed plus 3x raised to 2/3. Okay? So, yung u natin again is kung ano yung nasa loob ng parentheses, that is 2x cubed plus 3x. Then, kukunin natin yung u prime, that is 6x squared plus 3. Ulitin lang natin paano nakuha yung 6x squared plus 3, applying the basic differentiation rule. Okay? So, yung derivative ng 2x cubed, that is 6x squared, and derivative of 3x is 3. Therefore, the derivative of g of x is equal to, drop the exponent, which is 2/3, copy the given, subtract your exponent by 1, then multiplied by your u prime. Yung nakuha natin kanina yung derivative. Then simplify further. So we get, okay, so ito, simplify yung exponent. So 2 cubed minus 1 is negative 1 cubed. Simplify further. Pagsamahin yung 2 cubed at saka yung nasa dulong parentheses, that is 2 cubed times 6x squared plus 3. Then copy your remaining function. Simplify further. We get, kasi negative exponent, dapat positive yung magiging final answer. So we get ito, and that is the final answer. Okay? So the final answer is 4x squared plus 2 over cube root of 2x cubed plus 3x. So manipulate lang po natin yung nasa ilalim na part. Okay? So dako naman tayo sa higher order derivatives of functions. So yung higher order derivative of functions, hindi lang isa ang pwede natin kunin. Okay? So note that one consequence of having the derivative function is that you can further compute the derivative of the derivative. Kung nakuha na natin yung derivative ng function, pwede pa nating makuha ulit yung derivative na nakuha natin yung derivative ng function. As it turns out, such higher order derivatives have important applications. Suppose that you start with the function f and compute its first derivative, f prime. You can still compute its second derivative, that is f prime prime. Its third derivative, f prime prime prime, and so on. So yung table na to, nagpapakita, okay, that there are other notations needed to familiarize when computing higher ordered derivatives. So, hindi lang first, meron tayong second, third, fourth, until to the nth derivative. Okay? So, yung nth derivative na to, kung yung makukuha natin derivative is constant na, so derivative of constant is 0, so doon na tayo titigil. Okay? So, let's say for example, computing higher order derivatives is no different from computing first derivatives. So kung alam natin kung paano kukunin yung first derivative, mas madali lang computein yung higher order derivatives. Example number 1. Find the first 5 derivatives of, ito yung function natin na f of x is equal to 5x to the 4th power minus 3x cubed plus 1. Ito yung original function. So first derivative, apply tayo ng constant multiple rules. So, drop the exponent, multiply by 5, that is 20. Subtract by 1, x cubed. So, yung 3x cubed naman, drop the 3, multiply by 3, that is 9. Then, subtract by 1, that is x squared. So, yung derivative ng 1 natin is constant, that is 0. So, wala na tayong pagkatapos ng 9x squared. Ito yung first derivative natin. So, dako tayo sa second derivative. Para makuha yung second derivative, gagamitin natin yung first derivative. Okay? So, ano yung derivative ng first derivative natin? So, same rule lang din. Drop the exponent. So, 3 times 20, that is 60. Minus 1, 2. So, yung 9x squared naman, derivative is drop the 2, multiply by 9, that is 18. Minus 1, that is x. So, this is our second derivative. 60x squared minus 18x. So, para makuha naman yung third derivative, gagamitin natin yung second derivative. Okay? So, the third derivative natin is drop the 2 times 60, that is 120, minus 1, that is x. Then, identity ng x is 1 times 18, that is 18. And this is our third derivative. So, sa fourth derivative naman natin, gagamitin natin yung third derivative. So, identity rule ng x is 1 times 120, that is 120. Yung negative 18 is constant sa 0 yung derivative. So, may iwan na lang si 120. And this is our fourth derivative. Constant na naiwan. So, last derivative natin is the fifth derivative. Lahat ng derivative ng constant is always 0. So, dito na magtatapos yung derivatives ng ating function. So, by the fifth derivative, we get 0. So, first derivative, 20x cubed minus 9x squared. Second derivative, 60x squared minus 18x. Third derivative, that is 120x minus 18. Fourth derivative, 120. And fifth derivative, that is 0. So, ganun din yung process para makuha yung example number 2. Another example. Find the second derivative of y is equal to 2x over 3x minus 5. So, ito, gagamitan natin ng quotient rule. Kasi, division yung process natin. So, meron tayong denominator which is 3x minus 5 rather, and our numerator which is 2x. So, mag-a-apply tayo ng quotient rule dito. Okay? So, to solve this, maglalat tayo ng uv. Okay? U para sa taas, then v naman para sa baba. So, maglalat tayo ng u. Ano yung nasa taas? 2x. Then, yung v natin, nasa baba, 3x minus 5. Then, kukunin natin yung derivative ng u at derivative ng v. So, yung derivative ng u is du over dx or du na lang. So, what is the derivative of 2x? That is simply 2. Kaya yung du natin is equal to 2. Punta tayo sa derivative ng v. Our v is 3x minus 5. What is the derivative of 3x minus 5? That is simply 3. So, dv natin dyan is 3. Then, punta tayo sa formula ng quotient rule. So, to get the derivative of your function using quotient rule, that is equal to what? To v times the du minus u times dv all over the square of your v. So, we get, substitution lang tayo, 3x minus 5. Ito yung value ng v multiplied by du which is 2 minus your u which is 2x times dv which is 3 all over the square of v which is the square of 3x minus 5. So, ito na yung first derivative natin. Okay, then simplify natin further. Distribute property of equality. So, 2 times 3x is 6x. 2 times negative 5 is negative 10. Negative 2x times 3 is negative 6x. Then, copy yung nasa baba. Simplify further. Combine like terms. 6x minus 6x is 0. So, may iwan na lang is negative 10. Copy yung nasa baba. And this is our first derivative pa lang. So, yung nahanap natin dito is the second derivative of your function. So, paano natin kukunin to? Gagamitin natin yung first derivative natin. Okay? So, quotient pa rin yung ibinigay sa atin. Then, gagamit tayo ng quotient rule. Okay, so kung saan yung u natin again dito is negative 10 nasa taas, yung v natin nasa baba. So, para makuha yung du, gagamitin natin yung u. What is the derivative of negative 10? That is 0 kasi constant siya. And the derivative of dv is what? So, chain rule tayo para makuha yung derivative ng v. That is, drop the exponent. Okay, copy the v itself, then subtract by 1 the exponent, then multiply by the derivative of your inside function. Ano yung inside function? 3x minus 5. So, what is the derivative of 3x minus 5? That is 3. Kaya nag-multiply tayo ng 3. Then simplify further, we get 6 times 3x minus 5. Simplify, or sige, gagamit na lang tayo ng 6 times 3x minus 5 here. So, to get the second derivative ng ating functions, that is, v natin muna, that is square of 3x minus 5, multiply by your du which is 0 minus your u, negative 10, times your dv which is 6 times 3x minus 5 all over the square of your v which is 3x minus 5 squared. So, the answer is 3x minus 5 fourth. Simplify. So, yung una maging 0, may iwan na lang si positive 10 times 6 is 60 times 3x minus 5. May cancellation na magaganap. Yung 3x minus 5 ka-cancel. So, may iwan sa baba, 3 na lang. Kasi nag-cancel sa taas. So, we get 60 over 3x minus 5 cubed. And this is the second derivative of your function. And this is the final answer. So, dako naman tayo sa implicit differentiation. So, most of you are sometimes faced with situations where you need to choose between expressing explicitly and expressing implicitly. So, of course, you will choose the one that is clear and not ambiguous. The same situation happens also in mathematics, na kung saan when we are dealing with functions. Kasi yung mga variables natin minsan nagkakasama-sama. Okay? So, hindi nagkakahiwalay. So, si x, minsan kasama niya si y. So, we have xy, ganon. Okay? So, a function is written in explicit form when it is expressed in what? In y is equal to f of x. So lahat ng functions that are dealt with in the previous topics natin are written in this form. However, there are times when mathematical functions are written in a more complicated form, wherein it is difficult or sometimes impossible to express y explicitly in terms of x. Such functions are expressed in implicit form. So let's say, for example, we will consider the following equations natin. So meron tayong y is equal to x squared plus 3x, at 3 lang pala. Then the second function is x squared plus 3y is equal to 4. So derivative ng y natin is what? Is 2x. So dy over dx is 2x. So para makuha naman yung derivative ng x squared plus 3y is equal to 4, we will equate the function to y. So transpose yung x squared sa kabila, then divide by 3. Ito na yung equivalent function of your second function. Saka na tayo gagamit ng differentiation rule. That is, dy is over dx is equal to negative 1/3 times 2x, or that is simply negative 2/3 x. Napakadali lang. Okay? However, may mga cases na kung saan it is totally impossible to rewrite the given equation katulad ng second function natin. Okay, let's say for example, x to the fourth power plus 2xy, magkakasama na sa x and y, minus y cubed plus 2 is equal to 0. It is in these instances, kailangan natin gumamit ng implicit differentiation. So because the equation is written in implicit form, yung proseso ng implicit differentiations involves differentiating each term of an equations on both sides, kasama na yung mga variable ng y. So to totally understand how this works, alalahanin natin that you're always differentiating in terms of x. Palaging x po yung i-differentiate natin. Thus, you must differentiate the x terms in the usual way. Kung paano tayo mag-differentiate o kumuha ng derivative, yun yung proseso para makuha yung derivative ng x terms. But for the y terms naman, the chain rule must be applied because y is defined implicitly as a function of x. So para mas maliwanag, meron tayong steps to follow. So to further guide you on the implicit differentiation process, ito yung mga susundin natin. Step 1, differentiate both sides of the equation with respect to x. Step 2, combine all terms containing dy over dx on the left side of the equation at yung ibang mga terms naman nasa right side. Step 3, on the left side the equation, we will factor out dy over dx kasi yun yung hinahanap natin. Then step 4 naman, we will isolate dy over dx by dividing out the other factor on the left side. For example, so we will find the dy over dx given that y cubed plus y minus 3x squared is equal to 2x plus 5. So paano natin kukunin yung derivative nito using the implicit differentiation? Okay? So ito, medyo madali lang to sa una kasi hindi pa nagkakasama yung x and y. So step 1, we will differentiate both sides of the equation with respect to x. So lahat ng x, gagamit tayo ng usual way of differentiation. Okay, of differentiating. Pero kung y naman yung variable, maglalagay lang tayo ng dy over dx. Pero i-differentiate din natin siya. Katulad ng pag-differentiate ng x. Okay? And then, we will take the derivative of each term with respect to x. So, paano to? That is, so yung nasa kabilang part natin, y cubed plus y minus 3x squared, derivative is, ito. Then, sa second naman, we will get the derivative ng kabila. That is d over dx times the quantity of 2x plus 5. Then, we will take the derivative of each term naman. So, derivative ng y cubed, that is power rule dropped, then minus 1, that is 3y squared. Since y yung variable natin, maglalagay tayo ng dy over dx. Okay? Then, derivative ng y natin is 1. So, maglalagay din tayo ng dy over dx dyan. Derivative ng 3x squared, constant multiplicity rule. So drop the exponent times 3, that is 6, minus 1, that is x. So dito sa 6x, hindi tayo maglalagay ng dy over dx. Okay? And then is equal to sa kabilang panig naman, derivative of 2x is 2. Hindi din tayo maglalagay ng dy over dx kasi nga x terms na tayo dito. So ulitin na natin, pag x yung differentiate natin, hindi na tayo maglalagay ng dy over dx. Pero pag yung y yung differentiate natin, maglalagay tayo ng dy over dx. So step 2, combine all terms containing dy over dx on the left side of the equation. So pagsasamahin na natin yung mga terms na naglalaman ng dy over dx sa left side. Okay, so sino-sino dito yung may dy over dx? Ito, si 3y squared dy over dx plus dy over dx. So sa negative 6x, itatranspose natin sa kabila, magiging positive 6x. That is step 2. Step 3, we will factor out dy over dx. So in short, ilalabas na natin. So dy over dx times the quantity of si 3y squared na may e1 plus 1 is equal to copy yung nasa kabila. Then step 4, divide both sides by kung ano yung nasa loob ng parentheses natin na nasa left side to isolate dy over dx. That is, divide both sides by 3y squared plus 1 and the answer is 2 plus 6x over 3y squared plus 1. And this is the final answer using implicit differentiation. Medyo nakakalito ng konti, pero madali lang to. Another example. Ito na. Paano pag nagsama si x and y naman? Anong gagawin natin? So let's say for example, given the equation x squared y plus 2xy squared is equal to x to the 4th power plus y to the 4th power, we will find the derivative of y in terms of x. So we will use the steps na meron tayo. Step 1, differentiate both sides of the equation with respect to x. So maglalagay lang tayo ng d over dx. That is step 1. Step 2 natin, we will take the derivative of each term with respect to x and also using the product rule naman. Bakit product rule yung gagamitin natin? Kasi nga nagsama na yung x at yung y na variable natin. Okay? Yun lang ay gagamitin natin sa left portion ng ating equation. So that is dy over dx times uv. Product rule tayo. So, kunin muna natin yung derivative ng x squared y natin. Okay? Yung x squared y muna. That is, x squared times dy over dx. Derivative of y is 1. Since y siya, maglalagay tayo ng dy over dx. Plus, copy yung y, yung derivative ng x squared is 2x. Then, simplify natin, we get x squared dy over dx plus 2xy. So, ito na yung unang derivative ng ating ng x squared y. So, kunin naman natin yung 2xy squared na derivative niya. Using product rule pa rin. So, by the way, sa product rule, yung formula ng product rule natin is derivative of your function is equal to u dv times v du. Or in short, yung first function multiplied, first term multiplied by the second variable natin, a derivative of your second variable plus your second variable multiplied by the derivative of your first variable. Okay? So, so dito sa case ni 2xy squared, okay, so, copy muna natin yung 2x, then imong multiply sa derivative ng y squared, applying the power rule. So drop, that is 2 times y. Okay, since variable natin is y, maglalagay tayo ng dy over dx here. Okay, plus, copy yung y squared, derivative ng 2x is 2 to get 4xy dy over dx plus 2y squared. So ito naman yung derivative ng 2xy squared natin na nasa left part. So ibig sabihin yung left part natin, derivative is, pagsasamahin na natin yung nakuha natin kanina, x squared dy over dx plus 2xy plus 4xy dy over dx plus 2y squared. Then kukunin naman natin yung derivative ng nasa right part. So, power rule pa rin. Derivative of x4 is 4x cubed. Derivative ng y to the 4th power naman is 4y cubed. Since y yung variable, maglalagay tayo ng dy over dx. Okay, so ito na yung derivative ng bawat terms natin. Step 2, okay, yun na nga, pagsasamahin natin lahat ng terms na naglalaman ng dy over dx on the left side. So, sino-sino yung may dy over dx? Si x squared, si 4xy, at saka si negative 4y cubed. So, pagsasamahin natin. At yung mga walang dy over dx, nasa kabilang bahagi ng equation natin. Okay? Then step 3, factor out yung dy over dx. Ilalabas na natin yung dy over dx. So, yung may iwan sa parentheses, si x squared plus 4xy minus 4y cubed. And then copy yung nasa right part. Then step 4, divide tayo both sides by x squared plus 4xy plus 4y cubed. Okay? Para ma-isolate natin yung dy over dx kasi yun yung hinahanap natin. Okay, so divide both sides by x squared plus 4xy plus 4y cubed. And the final answer is 4x cubed minus 2xy minus 2y squared all over x squared plus 4xy plus 4y cubed. And this is the final answer using implicit differentiation. Okay, for the conclusion, these are the other derivative rules of functions that cannot be differentiated using the rules from the previous lessons. Hindi kayang isolve ng mga basic. We have the chain rule, that is dy over dx is equal to dy over du times du over dx. Katulad din siya ng general power rule, that is d over dx u raised to n is equal to n u raised to n minus 1 times u prime. Higher order derivative, successive differentiation, first derivative, second derivative, third derivative, until to the nth derivative. That is higher order derivatives. And the last one is the implicit differentiation, kung saan magkakasama yung x at saka yung y. Differentiating each term of an equation on both sides, including those that contain the variable y. So, hindi lang si x yung kasama sa implicit differentiation. Okay, so we have an last table. Saan nga ginagamit yung mga pinagsasabi natin dito? So, a function is called a position or displacement. Pagdating ng grade 12, meron tayong subject which is the general physics. Doon na i-apply natin yung concept ng calculus. Okay? So, a function is called a position or displacement. And the first derivative tells us how fast a function is changing over time. Okay, ibig sabihin, na yung first derivative natin or slope of a function directly relates to a function's velocity. So yung y prime natin or the first derivative, it talks about your velocity. Pero yung function natin, y is equal to f of x, it tells about the position or location, displacement, or distance. Okay? Pagdating sa physics. Yung second derivative naman natin tells us how fast the first derivative is changing. Gaano kabilis yung first derivative na magbago. So, ibig sabihin, we can look at how fast the slope is changing. So, yung second derivative naman natin, application is acceleration. Third derivative naman, sometimes called the jerk. Okay? Pag sinabi natin jerk, that is a sudden movement. Okay, ibig sabihin meron pagbabago sa acceleration. So if you picture yourself riding in a car and the driver suddenly accelerates or quickly slams on the brake, so ano mararamdaman ng katawan natin? So you will feel a jerk in that direction. Okay, so yun yung ating third derivative. So on. So sa fourth, we have the snap or jounce. For the fifth, we have the crackle or flounce. And for the sixth derivative, we have the pop or pounce and others. So ito yung mga applications din ng ating calculus pagdating sa general physics. Okay? So for the higher order derivatives naman, it involves successive differentiation. A higher order derivative translates into a series of change functions derived from a single functions. In a similar way, you often encounter successive changes of things around you. May mga pagbabago which lead to improvements. Change is the only thing constant in the world. Okay? Tanging pagbabago lang yung constant sa mundo. You have to find ways to keep changing for the better. For the implicit differentiation naman is performed in functions that are difficult to express directly. So mahirap i-express directly. As a result, the differentiation process takes longer than usual and is also a bit confusing when not properly carried out. This is the same for the things you cannot express directly. They may imply the right message, but the receiver might interpret them incorrectly when not properly stated. So ito yung mga application ng topic natin today. See you on our next topic.